Hello guys, in this video we will be learning about deploying our ML model and creating an API which can be used with any front end to deploy our machine learning model and utilize its classification or prediction capabilities to better improve your software. So we will create this video and divide this video into two parts. The first part would be to creating and exporting our ML model, and the second part would be to create an API to host our ML model. Now to create an API, we will use the simple Flask library in Python. And to create our ML model, we will create a simple classification model on the very famous iris dataset. Now, the steps for this would be same for deploying any ML model you want to deploy. So let's start by creating and exporting our ML model first. So for this, we will look at our dataset and create a classification model. To create the ML model on web, I'll be using the Google Collaboratory. I'll be going on to Google Collaboratory and creating a new notebook. After creating a new notebook, I will just show you which dataset we will be using. So we are going to use the very famous iris dataset. Now this dataset contains of flower details. It has the type of it has the type of features which are present in a plant, and it then classifies as class of iris plant. Now it has the columns like sepal length, sepal width, petal length, and petal width. The type of feature it is can be seen from the official website. Now, this dataset is so common and so widely used to teach and learn machine learning that it is pre-included in the scikit-learn datasets library. So, moving on to the classification model part, we will create a simple collaborately as I mentioned before. On our collaborately, let's rename it as iris classification. Now, the first step here would be to import all the libraries which we will use to create our ML model. Now, the libraries we will be using will be the scikit-learn library. And from the scikit-learn library, first we will use the datasets to load our iris dataset. You can also download the iris dataset from this site and import it using pandas as well. So I will use the load iris function which is present in the scikit-learn dataset submodule. Then to create the classification model, I will be using the simple Gaussian classification model. You can use any classification model of your choice which will perform better on the given case. But according to my calculation and my trial, the naive Bayes model will work here pretty well. So I will import the Gaussian NB dataset model. I'm also importing the train test split so that I can use to create my model. And in the end, I will just import and matrix. Yeah. So these libraries I'll be using to create my simple machine learning model to classify the iris dataset. Now this next step would be to loading the dataset. To load the dataset, I will just store it in a variable iris and just call the load iris function which I imported. After doing this, I'll check how this model looks. First, let's run this code. So iris dataset, as I mentioned, contains of four features: the sepal length, width, petal length, and petal width. So this dataset is stored in a form of key value pairs in the scikit-learn library. I'll show you how it looks. So after I run this code, you can see that it gives me all this data in form of a key value pair where all this data is stored in the data key. It has other features like the target, which is the prediction which we have to follow. So while creating the model, the target would be our y array and the data would be our x array. It also has things like frame, the target names, such as what would the zero value in target stand for. So the zero value in target stands for Setosa class, 1 stands for versicolor class, 2 stands for Virginica class. Now this target names would be useful to create our API later on, as based on the output generated by our model, we would display what class it belongs to by mapping it directly with the target names. Now let's see this in general. Cancel. Let's just see what keys this iris dataset have using the iris.keys function. As you see, we have data, target, frame, target name, and other such keys as well, which can be used as and when required. Now, let's split our dataset into X and Y for training. So as I mentioned below, the X would be our data, our iris.data, and Y would be the iris.target. In this way, we create our feature and target. Now let's split them so that we can use them for training and testing. I'm splitting it into Y train Y test and X train X test. I will pass in the X and Y, which are the features and target. Let's keep the test size to be 0.3 and keep it as random string. So this splits our dataset into X train, X test, Y train, and Y test. Now let's create our model and train it on the training dataset. So I will create a classifier on the Gaussian algorithm. To do that, I will just call the Gaussian function to classify the to create the model. Then I will use the clf.fit function to train them on my training dataset. After this, it will train my dataset, which can be used for further classifying. Now, if you are new to machine learning and are not understanding what I'm doing, then you can directly check all these functions on the official scikit-learn documentation. If I go here and see on examples or supervised learning guide, I can see all these functions which I'm using here and see what they do. So basically what I'm doing is to train my machine learning model. I'm first segregating my dataset into the features which I'm using for training, and based on those features they will predict an output y, which is my required output. So I'm first segregating it into that, and then I'm further segregating these data to create the training set and testing set so that our model does not overfit and works on all type of generalized data. So our model is created till here. After this, we will see how good it is working by predicting it on the test dataset. So for that, I will use the predict function and pass in the y test to predict. I'll also see the accuracy score which is provided. We imported this function in the above step. I will run the training code. It is y test here. I'll run this. I'm getting an error here saying, yeah, sorry. Instead of y test, we will predict on x test. So on predicting with X test, we get the Y pred, which we test with the Y test, which is the actual target value, to see how much accuracy our model is giving. Now, accuracy score of 1 indicates that our model is performing brilliantly and it is giving us an accuracy of 100%. Generally, this means that our model is overfitting, but this dataset has a small size and it performs really well and performs 100% most of the time. In other cases where our dataset is really big and if you are getting an accuracy of 100%, you need to do some hyperparameter tuning to make sure that the model generalizes better and performs on all the test cases. Now, this way we have created our model CLF, which can be used to predict the output of the data. So, after this, we need to export our model. To export our model, we will use something called as the Pickle library. If you don't know what Pickle library is, I'll just go to their site. So, Pickle is used to store the model, or serialize and deserialize a Python object structure. It can be used to store all types of model, and to store those models, all we do is we write two lines of code. First, we'll need to import the Pickle library. After doing that, we will create a file, let's say model.pkl, and we will give it the wb access specifier. Wb access specifier means that it can update the file and name it as file. Then we will just pickle.dump classifier into the file. So pickle.dump will basically serialize our classifier object and dump it into this file and save it. So if I run this, our file gets saved as model.pkl. If I go to the variables here and see, I can see that file is loaded. I'll just download this file so that I can use it to create our API in the next step. Once this is done, I will just show you how I can load this file as well. To load this file, we'll just call that file again, and instead of wb, we'll pass in the rb as the access specifier, and we'll just give data equal to pickle.load file. So our data will contain now the deserialized CLF model, which can be used to predict. I can use it to predict this, and I can also use it to calculate accuracy on this model as well. So after this, you can see that it is the same model which is giving us the accuracy of 1.0. Now, this is the end for our creation of machine learning model step. After this, we will move on to creating our API using the Flask library in Python. So for that, just let's create a new folder where I'll just go to VS Code. I'll be using VS Code as my code editor in this. You can use any code editor of your choice. After going into this file, first thing we'll do is in this folder, we will import our model which we have downloaded. We'll just save it in this folder, as we'll need to use this model to send our API request. I will create a main.py file. After creating this file, let's go to the official Flask documentation to get the starting template so that we don't have to write the code from scratch. So let's just go to our quick start and import this code. To run this code, we just need to pass in the app.run here. Now, app is the Flask instance which our file has created. writing app.run basically means that when this file python main.py is called, we just need to run the app.run function. Now let's just run this function and see what it gives us. It should ideally return us hello world on the given URL. So let's boot up our terminal and write python main.py. So as you can see, our Flask app is running. It is currently running with on production mode. It is having debug mode as false. So you can see that we see the hello world. Now, what this Flask, if you are new to Flask and don't know how Flask works, so basically it runs on this URL initially, and on if we use the routing method as app.route, and if the route goes on to this route, it returns whatever is given in the function defined for this route. I can do some processing here and write my processing code, and that processing code can be returned dynamically using this route. I can create multiple routes as well. So if I create, suppose, a predict route where I want to predict something which we will create for our API. So after doing this, if I go on the web page and go on to the predict route, I'll just have to reload this as well. I'll change the app.run as debug equal to true. So it reloads every time a change has occurred in my main function. What is this? Yeah. So the function name here has to be unique every time. It cannot have the same function name for two different routes. As you can see, it is now active on debug mode. So if I follow this link, it will give me hello world, and if I go to the predict page, it will give me the predict out. I will just cut this now. Yeah. So this way we have created our basic Flask application. Now we will import something called as request, which is mentioned and present in the Flask module itself. Request can be used to access different HTTP requests which we can give to create our APIs. Now things which are included in request are, request can be used to target APIs. It provides us with different methods as get, post, etc. To specify which method our app.route should specify is, we can specify it as a methods array. We can specify that it can allow get, or it can also allow post, or it can only allow a single request as well. To see if that is correct, we write if request dot method equal to post, then only return something, else we return 404. So if we go on this route again on the web page, by default on reloading the web page, it will send a get request to this route and it should give me an error. So if I run this code, you can see that it gives me method not allowed, which is given in the terminal itself, as it only accepts post request. Now, to see or send a post request, there are certain extensions which you can download from the VS Code, or there is a tool called as Postman. Now, you can download Postman from their official website, or you can use the inbuilt on the VS Code. So you can download Postman and create your setup and do the quick steps which they specify after installation, and come back to this video to further create the API. After downloading Postman, I'll open the Postman server. I'll just create it side by side so that we can see what is happening. It is loading. So after it is loading, I'll just create a simple API testing methods here. It is already been created for me, so I won't change it. So just skip this. Yeah. So this route should give me a predict response which we had specified here. So as you can see, if I send a predict response here, it gets hit to my terminal and I can see the predict is outputted. Now, our main thing was to create an ML model. Now we have exported our ML model already, and it takes in data from the request parameters. Now to pass those parameters, we will go into the body of this, go to the raw section, and in the JSON section, we'll specify the variables which we need to pass to our ML model. Now these are the features on which our ML model was trained on. So to access this, we'll use the request.json function and print the data. On saving it reloads. Now if I send the request again, all this data will be stored in our data variable. So as you can see, all this data is stored in my variable. Now my classifier model has to be open. So similarly as we did on Colab, I will write the code to load the model equal to pickle.load f. Okay. So I have not imported pickle here. I will import pickle. If pickle is not installed on your system, you will have to install it using pip install pickle, and pip install flask is also necessary to run these codes. After doing this, I can use the predict function after loading this. Now, to pass the data here, we need to create the data in specified format. Now, the format for that is, let's create a test variable which is an array of array, which consists of data dot sepal length, then it is data sepal width, data petal width, petal length, my bad, and data petal width. This way we create our data required to predict. And if we print this, let's store this as output and print the output. It will return us the predicted value for the output. Let's just comment this out. Let's just run both of these as well. So what I have done here is, first I have accessed all the data passed on the post request using the request.json method. Then I'm loading my classification model from the serialized pickle file. After loading, I'm creating the test which has to be passed into the predict function in the format required, which is an array of array. So the predict function or the classifier takes an array of inputs to predict the output. Then I'm printing the output. On running this code, I can see that it is taking some time to run. It gives me an error saying sepal width is not defined. So yeah, so instead of capital S, it is small s. Let's just check if there are any other errors. Yeah, and run the code again. Yeah, you can see that it gives me output as class 2. So class 2 can be found out using what type of what class it is. For that, let's just import the sklearn.dataset here. Since I showed you in the beginning what all features are present in the sklearn.iris data. Let's just load it here itself. let's just store the class flower as iris. The name of features are target name. Let's just print the iris.keys so that we know what all keys we are working with before doing this. Let's send the request again. I'm rerunning the code. You can see that the things present in the iris dataset are the data, target, and target names. So I just need to write the target names here. Target names, and the target name required is the output. I'll just target as 0 since it was an array, and print the class flower. Yeah. Let's just print this. On printing, you see that it gives me Virginica, as this is the class which is predicted or classified based on the given input. Now to simply return this as API format, we'll just create it as a dictionary or a JSON format, and we write class and give it the class flower as output. We can also call in a success variable to see if our output works correctly or not. Now, on again running this code, we can see what it is given. It is given as title not defined. It is given an error that this does not work. So in JSON, we cannot pass it like this. We'll have to pass it as string. Once we run it again, you will see that we get our API response as class Virginica on processing of the given input. If I change the input, suppose let's say 1.9, let's say this 1.2, let's change this to 3, and now run this code again. We get the class as versicolor. So you can see that our model is predicting based on the given features and giving us the output. So in this way, we have successfully deployed a simple machine learning API on the model which we have created. Now this is simple processing which we have done. If we have suppose a model which is of image classification or something, then we first need to take in the image from the URL. Then we need to apply the same processing steps which we have applied while creating the model. So if we have a categorical variable, then we need to label and code it to change it into an integer variable. If we have an image, then we have to apply all the processing steps such as pooling or reducing its filter, applying a filter through it, reducing its pixel values, or changing it to black and white for further processing or classification by model. All those processing steps have to be done before passing it through the predict function. And after creating the data in the suitable testing format, we then predict it and then output it as API or through anything. We can also create a website through this using Flask, where on instead of get we just pass in post as well. And when we submit the form present on website based on the uh, request sent, we show different HTML content using Flask as well. This is something as a challenge which you can try to create a website on this method, where on the get method you will return an HTML containing form which will ask for all this data, and when you submit that form, it should target the request.method equal to post and process that data and return me an HTML with my outputted class present in the HTML as dynamic content. To do how you can do that, you can go to Flask documentation. They have mentioned different routing, the variable rules, which different URL indications, how you can do this, and you can see how you can target different HTML and HTTP methods which I mentioned. So thank you for watching this video, guys. If you enjoyed this video, do like and share the video and subscribe to my channel so that I can create new content for you. If you have any doubts or you want me to explain something in more detail, or if you did not understand this section, do comment down below so it will help me improve as well. Thank you for watching.